want to learn how to manage your own investments? Are you ready to stop paying investment management fees and start building wealth? The DIY Investing Podcast is dedicated to providing you with the knowledge, skills, and resources you need to be a better investor. Learn how to make investments through the use of fundamental analysis, mental models, and business management insights. Now, here's your host, value investing expert, Trey Henninger.
Hello and welcome to the DIY Investing Podcast. My name is Trey Henninger and I'm your host. Be sure to subscribe to the podcast to get more great investing content. If you're listening on YouTube, also hit the like button on this video. And if you're listening on any other platform, your 5-star ratings and reviews are a great way to support the show. So let's dive on in. I'm excited to do this episode today. I think it's going to be a good one. So today's episode is near and dear to my heart. It's going to be focused on engineering mental models, why engineers make good investors. Now, your podcast host is an engineer by training, so I'm a little biased, but I think I can use that bias to potentially provide some valuable content, some valuable input here. So let's dive on in to some engineering mental models, and then I will use those as an example for why I believe engineers make good investors. First and foremost, so we're gonna talk about 5 different mental models today, which I think is valuable. I will try to not spend too long on each one to provide the high points, and then we can dig into them in later episodes, or you can ask me questions and we can talk about them in the future. But I think they're very important. You're going to know a lot of them anyway. So let's see. The first mental model that I want to discuss today is margin of safety. The second mental model is backup systems. The third mental model is scale. The fourth mental model is failure points. And the fifth mental model is leverage. So as investors, engineers, or otherwise, you've probably heard of some of these, maybe all of these, because they have been commonly used in discussions of investing. First and foremost being margin of safety. Margin of safety, if you are not aware of it, is not originally an investing concept. It's originally an engineering concept. And the engineering concept background around margin of safety is very simple. Imagine you are engineering and constructing a bridge, and you need to have, cars, trucks, vehicles, and transportation all go across this bridge. What you would do as an engineer is you would calculate what you expect the total amount of traffic going over that bridge at any one time to be. And let's say you determine that you think that there will never be more than 10,000 pounds of weight on that bridge at any one time. Well, if that's your calculation, that you think the max amount of weight on that bridge at any one time is going to be 10,000 pounds, now you can go about designing and building the support for your bridge to make sure it can hold up 10,000 pounds. But what you do is you don't actually build it to support 10,000 pounds. If you think that 10,000 pounds is the max that the bridge will ever hold, you're going to design your bridge to hold 20,000 pounds or 30,000 pounds. And the difference between those two numbers is your margin of safety. You're saying, I think that the max weight that I'll ever have to hold is 10,000, so I'm going to build it to 20,000 or build it to 30,000. Because you're doing this for 2 reasons. One, you may be wrong. It's really hard to predict the future and to understand the true mass limits that you might have your bridge exposed to, and 2, that provides additional safety in the sense that not only could you be wrong, but if you are actually correct and it only needs 10,000 pounds, it provides actual error safety so that as the bridge begins to wear and tear, year by year, the amount of weight that bridge can hold will steadily drop. So this is not often understood, but as cracks appear in a bridge, in some of the support columns, the amount of weight it can hold goes down. It doesn't mean that it can suddenly not hold the amount of weight that it needs to, but it means that it's going to start losing some of the design weight that it was designed to hold. So if it's designed to hold 10,000 pounds, Or if it needs to hold 10,000 pounds, it would be designed to hold 20,000 or 30,000, because as cracks appear, as a decade of wear and tear goes by, that 20,000 might drop to 18,000 or 17,000 or 16,000. And you have a large enough margin of safety so that you never have to worry about the bridge not being able to hold the 10,000 pounds it needs to hold. So that's where margin of safety comes from. Obviously, as an investor, we think about it in different terms. In my episode 95, I talked a little bit about how margin of safety can come from many things, not just price. High-quality companies have a greater margin of safety than low-quality companies. Durable moats have greater margin of safety than companies without moats. And lower prices provide a bigger margin of safety than higher prices. And so that's how investors use it. But this originates from the engineering disciplines. And it's one reason why engineers can make good investors, because I believe that margin of safety is the number one most important mental model that investors need to understand. Now, I'm accepting compounding because I think compounding applies everywhere in life, and certainly compounding is paramount. But if we're skipping compounding and we're talking about how do investors actually apply mental models, margin of safety is the most important mental model that you need to understand. Therefore, engineers who would intuitively understand margin of safety, because it's used throughout almost all engineering disciplines, I would assume that all engineering disciplines use this mental model in some form or another. It's very important. So let's dive into the second mental model, and this may or may not be talked about as much by investors, but I think it's still very important. So the mental model is backup systems. As an engineer, one of the things that you learn to understand is that when you're designing a system and you're engineering something, you need a backup in case the system that you design fails. So the obvious, clear example here that would be a nice one to talk about would be something like loss of power. So if you're designing a system and you need a manufacturing facility. You may hear my cat in the background, so I apologize for that. But if you need power to run a facility, to produce equipment, to manufacture goods, then your system needs that power. And so one of the things you will do is design a backup system, because what happens if the electrical grid goes down, or what happens if some electrical switches fail, or some connection between the power source and your equipment goes awry. This is a very common thing occurs, and it's very common, of course, in many different businesses, especially if you invest in any business that manufactures anything, they will have to understand how backup systems are used. So it's helpful if you're looking into operations and manufacturing type businesses to understand this as well. But what happens if you lose power? Well, if you lose power, the plant might shut down. And if the factory shuts down, you're going to start losing millions and millions of dollars a day when you're not up and running. If you're producing iPhones and you can't produce iPhones anymore, time is money. People want to buy iPhones. People want to buy the new PlayStation 5. People want to buy the new Xbox. And you need those plants to be up and running, and they need power to do so. So an engineer would design a backup system. That backup system is meant to provide power in case your primary power source fails. Common, easy way to understand a backup system would be something like an online generator. You know, you can get these for your house, and so you can think about it in terms of that. If you're in a hurricane or there's an ice storm and something causes the power to fail at your house, what happens? Well, if you don't have a backup system, then you have no power. Now, your refrigerators are going to, the food in your refrigerator would go bad. The food in your freezer might go bad. You might not have air conditioning or heating that you need to stay safe and functioning well, safely. Or you can buy a standby backup generator for your house. And what the generator will do is the same thing that you would see in a corporate environment. The generator would be designed to detect fluctuations in the power, and as soon as a fluctuation in power is seen or a loss of power from your primary provider goes away, the backup generator would kick online and provide power to your house or provide power to your factory. And these types of backup systems are designed throughout industrial processes and throughout an engineering's mindset. You're not just designing for loss of power, you're designing for all sorts of failure mode and failure conditions. And so by thinking in this way, an engineer is able to come into investing with an advantage, because you're going to do the same thing as an investor, or you should do the same thing as an investor. The question you have to ask yourself as an investor is, what happens if something goes wrong? What happens if my company loses a customer? What happens if my company's management steps down or retires? What happens if a new competitor comes into the marketplace to compete with my company? What is the backup that protects me as an investor, besides the margin of safety concept? So by what means is my company protected? And this would be stuff like a moat. Companies that have moats, companies that have the ability to fight off competitors, is the sort of backup system you're looking for in terms of analyzing a company. Obviously, a good backup's always buying at a low price, but you're trying to think in terms of, how can things go wrong with my company's performance? What are the pieces that can go wrong, and how am I going to make sure that this company is not simply going to go bad? For instance, if a recession were to occur, is my company going to go bankrupt? Is my company going to have a loss in earnings, and how do they deal with it? You can look at how they dealt with past recessions and that sort of thing. But it's a useful way of thinking, because backup systems allow individuals and companies to adapt to changing times and to adapt to things without everything becoming a black swan. Okay, next to talk about is scale. Scale is mental model. You've probably heard in the investing concept stuff like economies of scale, and how by being larger you can be more efficient. And this is another engineering-based concept. The standard way it's explained is in terms of basic geometry that you might have learned in high school or middle school. And the idea is that if you think about the volume of a sphere increases faster than the surface area of a sphere. And this is important in terms of many different corporate applications, in the sense that by producing, let's say, larger holding tanks for products, you're going to use less input, like metal or plastic, by having the surface area grow. You're going to have less surface area growth, which is your plastic or your metal, and more volume to hold product as the vessel gets bigger, so that you can have a huge economy of scale by being able to produce vessels that are 100 feet in diameter versus only 10 feet in diameter. And of course, that's extremely expensive to build a vessel that's 100 feet in diameter. But on a per volume basis, it's substantially cheaper than producing one that's only 10 feet in diameter. And so that economy of scale can accrue to shareholders and accrue to profits for the company that's larger and is able to operate at scale. I mean, this is an engineering-based model, and engineers use this throughout a lot of areas to understand when it's important to scale things up and gain the benefits of being larger. But this is one of the mental models that's commonly understood and commonly talked about as investors. So it requires a little bit less explanation, because it all kind of intuitively works there. Basically, as companies grow, some companies are able to achieve economies of scale. The idea here is that you have a fixed cost to operate at a large scale. Something like Amazon, they need a certain number of warehouses in order to operate at a large scale, operate throughout the United States. But once those warehouses are built, they can accrue additional profits without building more warehouses, which means they're able to build a larger amount of profit than their competitors on a per square foot basis, because they have a huge fixed cost base. And that scale means that you're not going to be able to easily compete with them without also growing to a large scale. It's very hard for a local retailer that only has a store in one city or one state to compete with an Amazon that has stores everywhere or warehouses everywhere and can use that broadened space to lower their costs below what you can compete with. So an engineer has an advantage here because they intuitively understand where this is coming from, how this works, and the different circumstances and different types of businesses that are going to benefit from the economies of scale. It's not every business. It tends to be the businesses that more have fixed costs versus variable costs. So let's dive into my fourth mental model, failure points. One standard method of understanding in engineering design is that the more complicated a system is, the greater the number of failure points. And that sounds simple on the surface. So the idea is that you want to keep things as simple as possible. So this is another way of, it's alluding to this idea of Occam's razor. The simplest explanation is usually the one that should be most likely believed first. But this is more when you design a system. And the same thing can be true when you're designing a company or when you're designing a valuation process, like I talked about in episode 96. Basically, the more complicated things become, the less likely it is that you're going to fail because there's more potential failure points. So one of the things that engineers get used to doing is finding ways to reduce the number of potential failure points in a system. Simplify things to the lowest number of inputs possible, and that way you can focus on attacking the limited number of failure points that remain instead of trying to cover many failure points. The easy explanation is the one I covered in the last episode in 96, talking about something like DCFs. A DCF, properly designed and properly built out, might have as many as 20 different assumptions and inputs. And every different assumption and input is a potential failure point. That means if any one of those inputs is off to too large of a degree, it could completely destroy the end resulting intrinsic value calculation. Meanwhile, the one I propose in episode 96 is like the Gordon growth model for valuation. And instead of a full DCF that requires, 10, 15, 20 inputs, it only has 3 inputs. What's your discount rate? What's your current earnings? And what's the growth rate in those earnings? And you can replace earnings with dividends. But basically, you only need 3 different inputs. It greatly simplifies things. It doesn't mean that you can't be wrong, but it means you have less points at which you can be wrong. It requires more conservatism to use, but it means that you're less likely to have a failure if you focus on less points of failure. So that's this idea of failure points, and it's very useful for investors because this applies not just to valuation, it applies to the portfolio design process. For instance, a common way of reducing failure points is this idea of when to buy and when to sell. Now, there's no way to get around the idea of knowing when to buy stocks. Buying stocks or buying a company is the first step in the investment process that begins your path of making money. But you don't actually have to sell companies in order to make money. You do have to buy companies in order to make money off of them, but you don't have to sell companies to make money off them, which is why some investment strategies reduce the failure point, and the potential failure point is selling at the wrong time, by creating a type of portfolio that's known as like buy and hold, or you have the coffee can portfolio, and each of these types of strategies eliminates the failure point of knowing when to sell by saying any company you buy, you just hold forever. You're cutting out a potential failure point. Now, because you're making your system less complicated. So this is something investors can learn from. Find the areas where you can make your system less complicated that could potentially grant you benefits. My fifth mental model for today is to discuss leverage. Now, leverage is, again, a term that you hear a lot in the investing community talking about bank leverage like debt, operating leverage like high fixed costs, leveraging other people's spending, synthetic equity, these types of things. But it's originally an engineering mental model and concept. The idea is very basic in that anytime you want to move a large object, you can use a small amount of force to use a large object as long as you have a sufficiently large lever. A famous quote around it is this idea that if you have a large enough lever, you can move the world. And this simply using different physics concepts where you apply force at one point, and if you apply force at the right point with the right fulcrum move significantly large objects, and you can have a greater effect on the output with the small amount of input if you put that input in the right place. So this concept of leverage is one of the things that astute investors can use to become or to really get outsized returns in the marketplace. Now, leverage, I've talked about in previous podcasts, has a lot of both positives and negatives. It can lead you to losses, but it can also lead you to gains. This idea of, you can take on debt is one form of leverage, and you can use that debt in order to have higher returns as long as your cost of debt is below the cost of equity and you don't have a default event. The same is true with rent. Rental leases are a form of leverage where instead of having to buy a retail establishment or land or a storefront, you rent it. And therefore you can leverage the value of that asset at a lower cost without paying the full economic cost. You're simply paying your rental cost. Likewise, you have stuff like operational leverage where you have high fixed costs. And this is what I talked about a little bit earlier in the podcast about Amazon. And with high fixed costs and low variable cost, each additional incremental customer doesn't cost you a substantial amount of money. So your high gross margins will eventually lead to higher operating margins as long as you can continue to grow revenue. Each of these ideas follows around the engineering concept that you can make small inputs create large outputs. And it's this idea that maybe by growing revenue 5%, you can actually grow earnings 20%. And this is often overlooked by investors that focus on growth companies. They might look at a company and say, I want to buy companies that are growing 20, 30% a year because that's how I'll get 20 or 30% year returns. Well, if you find the right company that's using operational leverage, you might be able to have 5% revenue growth and 10, 20, 30% earnings growth because of the way their operational leverage works within the company. So you don't necessarily need high revenue growth to achieve high earnings growth or high dividend growth. So those are the 5 key engineering mental models that I wanted to address today. We have margin of safety, the absolute most important. You have backup systems, scale, failure points, and leverage. So I think engineers make good investors because in large part they think in the way that can allow them to reduce their mistakes. The process of engineering and designing things is the process of trying to anticipate failures and trying to ensure that failures don't destroy you. The number one rule of investing is very similar. It's don't lose money. So when you're designing an investing strategy, you're designing a portfolio, you're designing a valuation plan or model around a company, you're trying to avoid failure. You're not seeking success. You're trying to avoid failure. And engineers are really good at trying to avoid failure, and I think that can be helpful for investors. So you don't need to be an engineer to learn from these mental models and to learn from these ideas. Mental models are useful because you can gain a broad, useful understanding of them without having that 4-year engineering degree. You just need to understand the mental models and how they work. So that's why I wanted to talk about them here today, and I hope that they will be useful to you. So again, the mental models covered today are margin of safety, backup systems, scale, failure points, and leverage. The full show notes for this episode, including my outline for today's podcast, are available at DIYinvesting.org/episode 97. Please remember this is a listener-supported podcast. If you've gained value from today's content, please consider supporting the show financially as a patron. Even as much as simply $1 per show or $5 a month would greatly support me in producing future free investing content. Thank you for listening, and until next time, stop paying fees, start building wealth.
Thank you for listening to the DIY Investing Podcast. Please visit our website and subscribe to our email list at DIYinvesting.org. for guides, videos, and resources to help make you a better investor.
The DIY Investing Podcast is presented for general informational and entertainment purposes only. I have not considered your specific situation or risk profile, and I have not provided investment advice. The information presented on the DIY Investing Podcast should not be construed as investment advice. The views and opinions expressed on the DIY Investing Podcast are those of the participants and do not necessarily reflect those of the show's host or sponsors. DIY Investing, its producers, sponsors, and host, Trey Henniger, shall not be liable for losses resulting from investment decisions based upon information or viewpoints presented on the DIY Investing Podcast.